Morning, everyone. My name is Jason Strait, and we are here today for 5 ways to improve performance through indexing. So if you're not familiar with who I am, I'm a Pragmatic Works employee. I'm a database architect with Pragmatic Works. I've written a few books. One of them actually has to do with just indexing. It's Performance Indexing for SQL Server 2012. So if you're looking for more information than what we talk about here today, feel free to pick that up. That covers a lot of what we're talking about today is actually in there. And then if you just want to look for some resources, you can go out to my blog at jasonstrait.com. And there's a number of resources out there as well. Enough about me. Let's talk a little bit about Pragmatic Works. This is the company that I work with. Pragmatic Works is a Microsoft partner. We do quite a bit with BI, but then we also, what a lot of people don't know is we do quite a bit with the database administration and data management side. And we've got a class coming up here, and I'll mention it towards the end, that is a 1-week performance tuning class. So if you're looking for more performance tuning information, check that out. And I've got a slide on that towards the end. So what we are here today to talk about, though, enough of the introductions, is indexes. And indexes are one of those things that's a fairly important part of SQL Server, but it's also one of those ones that's very easy to overlook. You know, when things when things are sitting there working right, it's easy to kind of just shift off of them and not be paying attention to them. And the problem is that if you don't pay attention to indexes on a very regular basis, you're going to be met with a little bit of disappointment because your usage patterns on your system change over time. They always are changing. Every time some developer goes out there and adds a new feature in there, you're going to see a shift in how indexes are used. And so you need to pay attention to what's going on. And in this session today, we're going to talk about 5 ways that you go through and improve performance through indexing. And these methods that I'm going to be talking about are fairly generic. I'm not going to be going into too many create non-cluster indexes and create them with 2 columns. We're not going to be talking really about that. We're going to be talking more about ways that you can go through and look at your indexes and find out whether or not there's a problem and then how to address that problem. So the first one that we're going to be looking at today is Lookup In Balance. And the Lookup In Balance is when you're looking out in your DMVs and you take a look and you see that there is an excessive number of key lookups. Now, key lookups aren't necessarily bad, but if there's an excessive number of those on the clustered index, you want to take a deeper look. And typically what I call excessive is any time the number of key lookups exceeds the number of seeks on the clustered index. And what this basically means is there are other non-clustered indexes that are going through and they don't have all the columns that they need within those indexes to satisfy the query. And in this case, you're increasing the amount of CPU because you've got to go and hit 2 indexes to get what you need. You're increasing the I/O because you've got to go to 2 indexes. And you're, of course, increasing the duration as well. And so you're expending these additional resources that potentially you don't need to if you take a little bit of care and feeding for that lookup imbalance. And there's a few ways that you can address this. The first way is just ignoring it. And this is what I see a lot of clients and customers doing, is they see that it's a high lookup rate and they're like, that's just the way it is and that's how our app works and no big deal. And then typically when I've gone through with clients in that kind of situation, I mentioned the fact that I'm being paid to be out there, so it's probably some sort of a big deal. So let's look at the other real solutions, not just the choosing not to do anything as a solution. And the 2 real solutions is you can move the clustered index. This is one that typically scares a lot of people, but I've seen this quite a bit. I see this a lot when it comes to dimension tables, where just some random value, some ever-increasing integer was chosen for the clustered index, and that's not necessarily how you access that dimension table every single time. And so I see it a lot in that kind of scenario, but you see it in other lookup tables as well, and reference tables. And it's basically where you've got the wrong clustered index on the table. And you can see this, and I'll show you some case studies around that. The other way to address this is just adding included columns into your non-clustered indexes. And that's just another way that move those columns over, and that way you can address those lookups and mitigate them. Now what I want to show you guys here is, in this first case study, is there's a pattern here that you can see in a lot of tables. Now I've changed the names of these tables to protect the innocent, but this is exactly a pattern that I got off of a client's system. And what we saw here in this pattern was that there was 877,000 user seeks on one of the non-clustered indexes. But then there was also, oops, I always forget how to make squares when it comes to zoom it. There's also 877,000 lookups on that table. And so there's a really nice correlation between these two. And as an audience member, you're probably thinking, hey, this doesn't happen that many times in production, and this is a pattern that I'm just making up. No, this I see all the time, where you've got some sort of non-clustered index, and in this case it was actually unique, so it made it even easier to take a look and see what the problem was. And in this case, what the problem is really that the column that you're using every single time, whenever you're accessing this data, is not what you're clustered on. You're actually clustered on the wrong columns. Now, I don't have the columns in here, and you would want to take a look at them, because it could be that this non-clustered index has, maybe it's 14 different columns. In that case, you probably wouldn't want to cluster on it. But if it's a narrow index, and you've got this kind of a correlation, what you're going to want to take a look at is whether moving the clustered index is a way to solve this problem. And as you can also see here, the clustered index itself is hardly ever used except for the user lookups. Now, from a second scenario, another scenario that I see quite a bit is where you end up getting a lot of user seeks, on the non-clustered indexes. And maybe there's one that's a little bit higher than most. But it's kind of distributed amongst all of those. Now, in this kind of a scenario, there is kind of two ways that you can look at it. One is you can consider the fact that there's very few user seeks and very few scans. And in this case, it might be good to move the clustered index then to the second index. But you're going to want to take a little bit of a deeper look at what the columns are. Oops. But it is possible that you would want to move the clustered index, and then maybe add additional columns into the other indexes for included columns. But what you're going to key on here is looking for the user lookups, the non-clustered index that gets the majority of the seeks, and then compare that to the seeks and the scans for the clustered index. And for a third kind of case study, and before anyone checks my math, I will tell you that that number is wrong. But sometimes when you look at your seeks, in this case we got 1.4 million, and you look at your lookups, which are at 1.5 million, now you still have an excessive number of seeks. I mean an excessive number of lookups compared to your seeks, because that number is still higher. But it's not that much higher. And in the case where it's not that much higher, and the non-clustered indexes, the seeks on those don't exceed the number of seeks on the clustered index, you're not going to want to move the clustered index, or not likely going to want to move it. What you're going to want to do is find out what additional columns need to be added to these indexes so that the seeks no longer, the lookups no longer happen. And this is what I mean when I'm talking about the lookup in balance. You want to look at where there's excessive number of lookups and take a look at the seeks on the clustered index and then the seeks on the non-clustered indexes to find out where you can address this. Now, of course, this works a lot better if I can actually show you guys a demo. And so I'm going to show you a demo that's got some tools in it that you can use to dig in and find out what exactly is going on with your indexes. So let me jump over to Management Studio here. And we'll start with this first demo here. Let me just increase the size of the font here. I know it's pretty easy to zoom in with GoToMeeting, but I can make it even easier so fewer people need to do that. So I'm going to start with the AdventureWorks database 2012, and then I'm going to run this SQL statement 50 times. And I'm using an exact SQL statement so that I can throw this into a temp table and not have to fill the page up here with tons of results. So let me just run through that. And that doesn't take any time at all. And we'll take our look at this case, this one example. And so what I'm just going to do is I'm going to go to Index Usage Stats. And Index Usage Stats is a DMV that provides a list of all of the times where an index was used in an execution plan. In this case, we're only caring about user plans, but it does also give you the last date in which these occurred, the times where the system was doing additions to that. But for this scenario, we only care about whether or not it's a user seek. So let's run this again. We'll bring up the results. And if we take a look at the results here, we're going to see that lookup pattern where we've got the seeks on the non-clustered index, and then we got the lookups on the clustered index. And we've got that really tight relationship there. And if you take a look at your indexes that you have in production right now, you will find, I can virtually guarantee you that unless you're really good at maintaining your indexes, that you're going to find this kind of a pattern somewhere. Maybe not exactly, maybe it's 51 lookups and 50 seeks, and there's a lookup from somewhere else. But you're going to see this out there, and that's going to be there. But once you have that, what's your next step? And typically, let's be honest, typically you're going to be looking at the entire database. So you're going to have to go through a large set of results. In this case, my database isn't being used that much, but so it's not that large of a result set. But you'll see a large set of results, and you'll need to go through there. Well, the first thing that you're going to want to do when you see this problem is, what index is it that we care about? So it's this, the IX sales order customer ID and the PK sales order ID. Well, let's take the PK sales order ID. And we're going to want to dig a little bit deeper into that. And the way that we can dig deeper into that is going into the plan cache and running a query against that. Now, if you've seen some of my other presentations, I talk about doing this quite a bit. SQL Server's plan cache stores all of its execution plans as XML documents. And so if you use a little bit of XQuery, you can dig in and pull that out. Now, I'm not telling you guys that you all have to run out there and start learning XQuery, but what you can do is you can steal this query from me and run it, and what it's going to do is it's going to look for all the execution plans that have a lookup for this database. And so let's run that, make sure I'm in AdventureWorks. And the results are going to come back fairly quickly, but what it can immediately tell you, though, is that for PK sales order, if you were to add these 3 columns into the non-clustered index, you'd be able to remove that need for a lookup, because that's what the lookup's going out and seeing. Well, this doesn't give you quite what you need here. What you actually want to do is take a look at the plan handle. And if we copy that plan handle out, make sure I got that copied. What you can do is with this other query I've got here, and what this query is going to do is it's going to take that individual plan, and let me open up that plan real quick so you guys can see what's in the plan. And for some reason I don't have that in here, so let's just make that a part of the query. We'll run this one more time here. Because it is useful to see that we do have that key lookup actually occurring here. And that's what's happening right here. And so what we want to do is we want to find the columns that were being looked up and being added then back into this non-clustered index. So if we take a look at this, we're going to pass in the plan handle. So we're looking at that one plan, and it's going to go through and it's going to find our index scan through all of the relational operators. And then from there, it's going to go up to the nested loop, and then it's going to traverse back down to pull back that non-clustered index. So I'll just run that, and it'll take a couple seconds. And you could, if you wanted to, run this against your entire plan cache and find all of the lookups, and then find all the clustered indexes that they're using, and then go and pull in all of the non-clustered indexes. I'm going to recommend against doing that. And you could do that just by deleting that off. I'm going to recommend against doing that because this is a fairly intensive query, and the times where I've done that, it's sometimes taken an extremely long time to complete without giving me any useful results. And so you go in and take a look at it plan by plan, and what it's going to tell you, though, is for this index, if you add in these three columns, you will not need to access that index anymore. And so let's take a look at doing that real quick. Where is that index? Let's go out to sales order header, go into our database. Sales order header, and the index that we're working on is, where is that index? IX sales order header, customer ID. We're just going to script that out. It says to add in those three columns, so we add in those three columns. Include them, go through and run that, and if we go back to the original script, we can run that original, and we'll turn on the execution plans, and we no longer have the lookup that was there previously. It is gone. And so these are kind of the ways that you're going to want to look at that lookup and balance. Find out where it is, find out what it's occurring with, and then dig into it that way. All right. So the biggest thing when it comes to lookup and balances is you want to look at when key lookups exceed, seeks, investigate why. Is there a strong correlation between one of the indexes and the non-clustered index, and the clustered index, and then consider whether you want to move the non-clustered index or if you just need to go out there and start adding included columns into the non-clustered indexes. Usage patterns will shift over time, so you do need to do this analysis. I would say on at least a quarterly basis, just take a look at your entire database and take a look at how the indexes are being used. Now, the second thing that you're going to want to look at with indexing, and a way to improve it is to look at your scan-heavy indexes. And I see this a lot when people are looking at perf stats, and they go up to the perf stats and they see, one of they see the read scans going really high, and you want to take a look at indexes where the seeks are exceeding the scans, and especially in the larger indexes. On the really small indexes where there's maybe 20 or 30 rows, it's not the biggest deal, but you get a table that's got a few million records in it, and when there's a lot of scans on that, you're going to start to see problems because of increased I/O, there's going to be more locking, which can lead to deadlocking. You may see your page life expectancy drop, which, all this ties into you're going to have an impact on your memory because the amount of the type of data that's being stored in memory is going to shift a lot, and you're going to be cycling through that quite a bit. Now, the metric that I usually see where people start getting concerned about this is they see full scans being high. And typically, if you're in a shop where you pay attention to perf stats quite a bit, you see full scans going high, and it's like, what do you do? How do you tie this performance counter into something that's happening on your system so that you can affect a change? And so if you see spikes when it comes to full scans per second, you're going to want to take a first look at DM index usage stats, and then take a look at the plan cache, like I did, a little bit like what we did with the Lookup In Balance. And when you're looking at this, what you're going to probably see something along the lines of is scans on your clustered index or one of your non-clustered indexes that exceed the seeks. Now again, if it's a tiny table or a smaller table, this may not be such a big deal because it's a smaller amount of data, and it may be that the fastest way to get your data is to scan it all. But when you're talking about your larger tables, you don't want to see this kind of a pattern. Why aren't some of the other indexes being used? Could it work off of table 1 index 3 or 2, and it's just not having enough selectivity? And so you want to examine the execution plans and modify those or add in the correct indexes so that you leverage other indexes. So let me take and show you how you can investigate that and some tools that you can do that to help improve your performance. So we'll go back in here and we'll take a look at scan heavy indexes. And so I'm going to clear out the cache, and I'm going to run these 3 statements. They should be done here any second. There we go. And we're going to go back to index usage stats and take a look at those user columns. And so let's run through that. In this case, we're going to see another pattern that we're probably a little bit used to. We've got user scans and user seeks. In this case, I didn't cause any user seeks to occur. We've just got everything that's happening on the user scans. And so we want to take a look at what's going on and look at the indexes look at the execution plans that are causing this activity to happen. And if you weren't aware, you can actually dig deeper into that. So let's just take this PK sales order header, sales order ID, and we're going to run another query, this time against the plan cache as well. But we're going to be looking at the physical operation and the indexes that are being used. And so we're going to be looking at a clustered index scan. And clustered index scan is, anytime that there's a scan on the clustered index, that's the name of the operation. And we want to take a look at the sales order header ID. And because, if you recall, out of the 3 sets of indexes being used, the scans on sales order ID were the highest. Oops. So we'll go to the editor. Let's run this query. We'll use the sales order ID. And we can dig into these, and now we've got the execution plan where that scan and that index are being used, and we can take a look at it. Now we can see right away that SQL Server actually has already solved this problem for us with missing index recommendation. And so there is something that we could do to improve this, and maybe it is creating that index. maybe it's not. We can take a look at the plan here, and we know that, hey, if we're selecting out of this and we're going to the clustered index, there's probably not an index on account number. And so we can improve this by adding an index on account number, which may be what the missing index is actually telling us to do. Now, if we need to look at some of the other indexes, we can do those as well. So let's just comment those out. But I'm hoping that people are seeing a pattern here where, oops, we don't want to do that. We wanted to uncomment this out. There you go. We'll run this whole thing, though, looking at just one of the other indexes with an index scan, because that's the operation that was happening there. Why did that do that? We want to execute. Why is it saving the results to report? I didn't choose that, did I? So I did excellently. Okay. We'll run that. We'll take a look at the results. And we've got that index scan and on the one index. And here's the plan. We can open that plan. We can start doing our performance tuning to find out what we need to do to fix this. In this particular example, I did a really dumbed-down version of forcing a scan. And so there's not much that we can do about this, but at least we would know that there's not really much we could do about this, and we can say, well, our application actually does have scans that are this high, and this is just how it works. Or maybe we turn around and we talk to the developers and ask them, hey, do you really need every single sales order ID and customer ID from your application at this point? You do need to do some cooperative work with your devs in order to solve some of these problems. And so that's the main pieces with scan-heavy demos. I mean, scan-heavy indexes. If you see where you've got the scan-heavy indexes, take a look at your usage stats. Then take a look at the plans that are using those indexes and determine what it is that you need to do to bring that down. And then as you get that work done, you're going to either reduce your perf stat, or you may find out that what you're using for your perf stat is actually incorrect for the usage patterns for your application. And of course, as a summary, as you get this removed, you may reduce your blocking. You may remove some deadlocking, which is what I've had happen in the past when I've had really heavy scans. And you may see that memory is better utilized because the data that you're actively using, and not this extra data because you're missing an index, is up there and properly allocated out. So the third way that you can improve indexing is using filtered indexes. And this is one that I really like to talk about because filtered indexes aren't used by very many people. Typically, if I've got a room of about 300 people and I ask who's using filtered indexes, I might see one or two hands go up. And filtered indexes is really one of those missed opportunities. And what a filtered index is you take an index and you just throw a where clause at the end of it. And what this is going to do is the index will only include your filtered rows, and so you're decreasing the number of rows in your index. Well, this is going to have an effect on your plans in a few ways. One is you're going to be able to improve your plan quality because you may have a situation where you wanted to only pull back results for California, but whenever you pulled up for California, you always ended up with a scan because it was so much of the rows in the table that it just fell over from a seat to a scan. Well, filtered indexes is one of the ways that you can help prevent that because you can make an index that just covers for California, and then everyone in California just uses that. You're going to improve storage because it's a smaller index. You may have something that you're querying where it's a report that's looking at the last 30 days worth of activity, and you only ever look at the last 30 days of activity. Well, in that case, build out a filtered index that only looks at the last 30 days of activity, that has all of the included columns and all that stuff in it, and that way you don't have to look at the last 7 years of activity. You've only got the last 30 days. Well, in that case, it's going to be much smaller. You're going to improve your storage time. The amount of time it takes to build that index is going to be much smaller. If you need to defrag that index, it's going to take less time. And the nice thing is that if you end up having to still scan that index, you're scanning a much smaller set of data than you would otherwise if you were scanning an entire database. If you can scan 10 megabytes of a 100 terabyte database, you're going to see some performance improvements. And that kind of ties into this case study that I've got here on the screen. You may have a table that's got nearly 100 million rows in it. It doesn't nearly need to be this many rows, but it has a large number of rows. And you may be seeing new data that comes in that represents maybe less than 1% of those rows. Maybe there's a rule, or because of downtime allowances, you can't ever rebuild your indexes. And you need to have high quality plans, and the indexes that are in place don't help with those new ad hoc reports that are coming in. And maybe somebody gives you an ad hoc report, there's no index that supports it, you don't have a large maintenance window, maybe you have 20 minutes to add an index. Well, a filtered index that ties in directly to that report and builds that report out to be the best that it can be, the fastest that it can be, that is that perfect case for a filtered index. And that's what you want to be looking for. Those circumstances where you're building indexes to support things that don't actually cover the entire database. Now, there's a couple issues here. Well, one main issue that comes up when you're using filtered indexes, and you have to be very careful about this. Your filter criteria, so whatever you use for your where statement on your filtered index, has to be inside the SQL statement that you're using for whatever your report or your query is. And you cannot parameterize it. And the main reason why you can't parameterize it is if you say that it's for everybody that lives in California, and the first time you run the report, you run it for California, and you expect it to use the filtered index, well, that parameter that's being passed in, SQL Server doesn't know that every single time it will be California. And because it doesn't know that it will always be California, it can't use your filtered index because it can't build out a plan that won't fit all uses and all variations of that execution plan. And so you have to be careful of that. But you can watch for this. You can find out when you've built out plans or SQL statements that aren't using your filtered indexes, using the unmatched indexes warning. And let's take a look at that, because this is where it gets kind of fun. So let's start with our filtered indexes. And so for our filtered indexes, what we're going to do is we want to take a look at building a report that brings back product ID 870. Product ID 870 is this water bottle. If you're like me, you drink lots of water, so you need lots of water bottles, and I want to find out where all the water bottles are being sold. So let's build out our report. And we build out our report. There we go. And it ran. We got all of our results. If we were to take a look at the performance, though, what we are seeing here is that it did one scan across, and there was 1,246 reads. And that seems kind of high. And let's actually run this again with the execution plan turned on, so we can see what was going on in the background. And we can see that there was a scan across the entire index. And so the entire index had to be read just so we can find out the details for one product ID. Now, I think that we can improve this. So one of the ways that we could improve this is building an index. Now, we do see here that it did recommend a missing index. And let's take a look at that real quick. So let's take a look at the missing index details. And I'm going to give away in a moment that we're actually going to talk about missing indexes a little bit more. But what I want to show you real quick is we've got a missing index recommendation here with a lot of included columns. And for me, a lot of included columns when it comes to missing indexes is something I really like to build, especially if I'm building it across the entire table. And to me, if I need to add in a lot of included columns, I want to find a way that I can filter that index, because I want to decrease the number of rows that are going to be built across that index. And so we're building our report for 870. Well, let's just filter the index then with all of those included columns for 800 to 900. And so we'll build that index. We'll get that built. And now if we rerun this, we can rerun it. We can see that we can see that it is using the filtered index. When it comes to the reads, we've now went from 1,246 down to 36. Now 1,246 really isn't a lot of reads when you consider most databases, but if that 1,246 was an order or two magnitudes higher, so it was 12 million, well, that would have been kind of a problem. And so using the filter index, we can improve this. Now, what I did mention in there, the problem with filter indexes is when you parameterize it. So the exact same query, all we're going to do is we're going to use a variable in here. We'll run that. If we take a look at the execution plan, we go back to the clustered index scan, so we're no longer going through just the one in, going through the filtered index. And we've also now got a warning that's showing up here on the select. Now the warning isn't showing up in the select message. It's not in here. But if you go to the properties, you can actually see where this warning shows up. If it'll actually, let's see here. There we go. And it's going to show up here as the unmatched indexes. Now the unmatched indexes, I could expand that, so let me expand that a little bit, show you what's all in there. That unmatched index is going to tell you the database, it's going to tell you the index, the schema, and the table. And all it's saying is that there was a filtered index that might have been useful for this query, but because of how you wrote the query, you couldn't use that index. If you are using filtered indexes and you are not checking for unmatched indexes, that's a time where I can tell you that you're doing it wrong. You need to be checking for unmatched indexes because I doubt that you're the only person building out indexes. Building out queries. There's probably somebody else, and they may not know what you know about filtered indexes. So if you're using filtered indexes, make sure that you're watching your unmatched indexes. And to just run a query to pull back every operation, and this is for the DBAs out there, if you want to find out every single time somebody has had an unmatched index, you can do a similar query that we had in the first two examples where you go and check the execution plan and bring back every occurrence of this. And so we'll just do that real quick. Run through that. We'll execute it and take a look at the results. And in this case, since I'm only running a few queries on my system, I only get the one unmatched index, but it tells me the query plan and the plan handle, so I can dig in and I can see where this occurred. And actually that query plan came back oddly, but it's that query plan. Not sure why that's coming back like that. They usually worked out, not sure why, but we at least know that that's what it is. And we can dig into that in some other session. So how do we fix this? How do we prevent the unmatched index issue? Well, what you need to do is you need to put that where clause from your filtered index into your query. Now this will prevent this query from running for product 720. That wouldn't work. But you got to remember what we're talking about is that we're building out a focused index for a specific use case. We're only intending that this is going to work for 870. I've just expanded it to 800 to 900 to add a little flexibility. And we're not saying it can only be used for 870. We're just saying it can only be used for this range. And so let's run that, take a look at what you get back. Because you don't get back perfect index, because you still want to do, the perfect execution, because you still want to be able to parameterize this some. And so what SQL Server ends up doing is it ends up doing index intersection between the two indexes. So they're both the indexes for product ID. It's just using both of them to get to its result set. And you don't end up with the best I/O. In this case, we get 49, and 49 is not as good as we had with with just the filtered index, but it's a heck of a lot better than scanning the entire index. And so it's one of those situations where if you have to parameterize it, you can get about the same performance as just having the filtered index and being precise, but it's not totally the best. But it's good enough. I mean, 49 compared to 1,246 is a vast improvement, and I can think that most applications with that kind of a performance improvement would be very welcome. All right, so let's go back to the slide deck here. And just to summarize, if you've got large indexes with a limited range of use, take a look at filtered indexes, because they may be the way to solve your problems. Because even if you end up getting a scan on those large indexes, it's going to be a scan against much fewer indexes. And tables with large number of rows, take a look and see how you're using that data to find out if the filtered indexes are going to be helpful. And this is going to improve your performance immensely because they're smaller, they're lightweight, they're agile. You can add them in a smaller amount of time. And so if you find out in the middle of the day that your 2 terabyte database needs a 1 megabyte index, you can add that with minimal impact. And you're going to see improved plan quality. If you can end up getting scans, seeks over scans when you're talking about moving from small data to large data. And then when you've got really smaller indexes, you're not going to be so concerned about getting scans, because having that tiny data instead of the smaller data is going to give you a much lower set of indexes, lower set of pages to go across. And so hopefully I've gotten a few of you excited about filtered indexes. They're a really great tool for SQL Server. Now the fourth area that I want to talk about is missing indexes. And missing indexes is basically when SQL Server is suggesting that you optimize some of your queries by materializing statistics. That is basically all it's telling you to do. I went through SQL Server basically saying I went through some statistics. If these were physical, I could have improved the performance of this query by X%. And that's kind of a nice thing to do, because that's free optimizations. That's work that you didn't have to do to figure out where there are possible improvements. There are 3 ways that you get to missing index recommendations. One is dynamic management views, and these are automatically collected and they sit out there and you can work with those. The second is the database engine tuning advisor, where you actually pass it a specific workload and say, tell me what's missing in this. And the third way is going to the plan cache. Now the plan cache is going to have the exact same information that the dynamic management views has. The benefit of that is going to the plan cache, you get to take a look at the queries that are associated with those missing index recommendations. And I really dig being able to do that, because as a consultant, if I tell you to add an index and I can tell you where it's going to improve things, that helps me prove the ROI for what I'm working on. And you don't have to be a consultant to want to be able to prove the ROI of what you work on, because just as a DBA, if you want to go into that annual review and get that big fat raise, you need to prove out what you fixed and what you made better. And leveraging the plan cache with missing indexes is a great way to do that. Now, of course, oftentimes when I talk about missing indexes, people are like, oh, I don't want to do that. Missing indexes are dumb, they're stupid, they're duplicates, they're there and I didn't ask for them. Yeah, get over it. Missing indexes, for the most part, are free performance improvements. All you got to do is write a query and you can make things better. Now you can pretend that they took a really long time. You can tell your manager that all the missing indexes that you worked on took a really long time. Maybe go see the new Superman movie or see World War Z, and then come back and say, I worked on this for how long is the movie? 2 hours. I worked on it for 2 hours. This is what I came back with. Maybe that's what you need to do to feel good about the missing indexes. Whatever can get you to be okay with them, do what you need to, because missing indexes are something that can really help you. And let me just show you a simple example of missing indexes. And I mean, recall that in the last few sections, as I was going through, SQL Server was telling me what indexes I needed to create. Now, in filtered indexes, I needed to add a filter in it to make it ideal. With the previous two, I could have just said, you know, don't do anything else, just look at this missing index detail, and that actually would solve your problem. But there's other scenarios that tied into those. But missing indexes are extremely useful. Let's just go through it. So let me run some queries here, and I'm just going to show you. And so, actually, let's turn on actual execution plans. So we'll take a look at these execution plans. We'll ignore this first one because that's just dropping an index. But when we talk about the second ones, what we're seeing, we see these missing index recommendations, you know, 99%, 96%. So look at the last two. Oh, there we go. The last two, 94% improvement, 94% improvement. You know, with all of these, there's an index that we could build that would make things better. And so let's look at what the actual recommendations are. So there's a couple ways that we can address this specific scenario. The first is that we can take a look at missing indexes details. And so we go to the missing index DMDs, we go to missing index details, we tie that into the index groups, then tie that into the index group stats, pull this all together, and what we're going to do is we're going to get an impact, which is the seeks and the scans times the impact. And then we're going to give it a score. And the score is going to help us determine whether or not, you know, how valuable the recommendation is. And for the score, what we're really looking at is total user count multiplied by impact divided by 100 times the seeks and the scans. And so we'll run this. And then taking a look at the results, what we're seeing is on sales order header, there are 4 recommendations. These 3 recommendations tie into the queries that I ran in this scenario. And we've got inequity columns, we've got equity columns, we've got inequity columns, and we've got included columns. Equity columns are any time you've got a query where due date equals X. Inequity column is due date is greater than X, or due date is between X and Y, or due date less than Y. That's the difference between your equity and your inequity columns. Now, your included columns are just additional columns that you can add in. Now, one of the takeaways I see from a lot of people when they're looking at missing indexes is, yeah, look at this. This is all wrong. This is all junk. You know, I got 3 index recommendations, and I could make just 1 index to do that. Well, of course you could, and that's what you would want to do. Missing indexes are when individual queries could have been improved because the stats that were on the index, the stats that were on the column weren't indexed. And we had 3 different execution plans, all using due date, 1 using order date, where if there was an index on due date and it happened to have order date as the included column, it would be improved. And that's what you need to do with missing indexes. You don't take them verbatim. You don't write a script that goes through and creates an index on every single recommendation. I did that once. It was a really bad idea. I ended up with 150 indexes on the table, and they were almost all the same. This is a long time ago. I wouldn't do that anymore because I learned. And hopefully you've gone out and you've seen this, and this is the problem. This is what people complain about. And so what you want to do instead, and actually before we get to that, before we get to the consolidation, I want to show you something else. You can also go to the plan cache to get this information. And this is where you tie it into the actual plan. I do have a link here. There is a variation of this that I originally worked with that Jonathan Kai's put together. The query that I'm using is just a little bit different. But I leave that link in because that's where I originally got the idea for developing this query in this way. Let me just run this. We'll take a look at the results. Now, if you notice, we get the exact same set of data. There just happens to be, there's actually 2 different plans that ran with order date. And we also here, it's off the screen, but we also have the queries that were run. And on the other side here, if I zoom in one more time, we've got the query plans. So by going to the plan cache and looking for the missing index element, we can find out what all the missing index recommendations are and the associated T-SQL statements and plans so we know what to test. And that's the reason why I like going to the plan cache. And all we're looking for in the plan cache is that missing index. And this missing index attribute element that's showing up here, this is actually what shows up in green when you look at the execution plan. So if we click on any one of these plans, this piece in green is the missing index element. It just looks prettier in the GUI. But now that we know that there's those 3 indexes that we want to create, we could actually consolidate them into a single index that's due date and order date. That covers for all 3 scenarios. We can run that. And if we go back through and we rerun these, all 4 of the execution plans no longer have missing index recommendations. We've improved the performance for every single one of them, and we had to basically do nothing. Now, I understand that a lot of people like to go through and they like to determine what all the indexes that you need are manually, and you take all the time. The thing is we work in a world where we need to be much more effective, and missing indexes is a way that we can be more effective with our indexing. And that's really what it's all about. They're free. I keep some, if you bring in a consultant to use them so that you can get basics done, so that when you bring other people in, actual more interesting work, you've gotten rid of the boring pieces where you're just working through things that have already been determined. And it gives you that time to focus on things that are more important. But remember, these are recommendations. You've got to validate the indexes, consolidate when necessary, review the associated queries so you know exactly what it is. And so those are the main things with missing indexes. I do highly recommend it. Now, the last way that you can improve performance on your system is by indexing your foreign keys. This is a fairly old school recommendation, a way that you can improve performance, but it's one of those ones that people don't necessarily see all the time. Foreign keys go through and they enforce your constraints across inserts, updates, and deletes. They're performed in the background. They're typically unseen until they become a big problem. And they do become a problem, and people just don't realize it because a lot of people don't look at those execution plans. And you want to take a look at it, and you want to see what's going on there. And the main problem with unindexed foreign keys is that those constraint columns, when you need to validate them, you've basically got 2 operations that SQL Server can do to validate your constraints. It can do a seek against the data, or it can do a scan against the data. And if you're doing a scan against it, you're going to increase the number of locks, you're going to likely have blocking, and potentially you're going to have deadlocking. And the deadlocking is one that I've seen quite a bit. I've actually been called in specifically for performance issues just because foreign keys weren't indexed. Because when those foreign keys were when they were running deletes against their sales information, it would go through, it would have to scan everything, it would block all across the system, and they would get deadlock after deadlock after deadlock because of all of these deletes. Now, the way to take a look at this, and the case study here that I want to show is, what's going to happen when you've got your foreign keys. And what we're talking about is deletes here. Deletes is where this really kind of nails people. Now, if we consider sales order header in this scenario, and we know that it's indexed on this side, we know that it's indexed on this side, and we know that for sales order header, it's indexed here. But where you don't tend to get the other index is on sales order header sales reason. That ancillary other lookup value will sometimes not be indexed. And this is what catches people, because people always make sure that, oh, the header table, we've got that, we've got the detail table, those are the big tables. Sales order reasons, oh, we don't need to cover that. Well, if we do a delete from sales order header, without having sales order header reason indexed, what's going to happen? Well, it's just going to do, it's going to validate here, it's going to validate here, and then it's going to delete the row. No big deal. But what about if we delete from sales order detail? Now again, indexed here, here, but not here. In this case, again, not a big deal. We're going to delete out our sales order headers, and nothing's going to happen here. It's not a big deal. But this third scenario, and this is the scenario that gets people, where you're deleted here. I mean, you're indexed there, you're not there. Again, index there, index there. When you delete out your sales order header sales reasons, and then you delete from your order header, you've got to scan the entire table, because it has to find every header record that has that value to make sure that's not being used, and get it deleted out before I can delete it out. And that's where you run into the problem, because you're probably, if you've got a sales system that's similar to this, you're probably adding in new sales order headers all the time. You're probably adding in new sales details all the time. And you've got to watch for that. And so let's take a look at this demo. So let's start by just creating a customer and a sales order header table and get those built up. Obviously, I built those up last night. All right, so what we want to take a look at here is we're going to delete out the max customer ID. In this case, the max customer is 699. Actually, let's go back here and drop these two tables. I ran through these demos last night, and if I don't drop these, my demo is not going to work perfectly. So let me drop those, recreate them. That'll take just a moment. All right, so the first row that's in the table is 701. We want to get rid of 701. We're going to do a delete, and what we're going to look at is the statistics IO, because that's what we really care about in this scenario. So let's just run through that. Our stats IO is telling us that there were 4,513 reads against sales order header. Now this kind of seems like a lot when for the customer delete we only access 3 reads. Now if we take a look, we're actually going to see here that there was, in the execution plan for sales order header, there was a scan. Now there's also a scan on PK customer, but we don't care about that one. What we really care about is the clustered index scan across our header table. That can be a problem in a busy system. And that's just to verify for the delete. Oh wait, no. Sorry, my bad. Looking at the wrong plan. There we go. Same explanation, wrong query plan. You can tell it's earlier in the day from where I'm presenting. Here we go, the clustered index delete, so we just got the one. And we're pulling back just this scan. And that's where the problem is. That really is where the problem is. Ignore what I said a couple minutes prior. If we index on sales order ID, on sales order header, the customer ID, make sure that the first one is it 700? Yep, 700. So we want to do our delete against 700. Instead of the 4,513, we get 2 reads against sales order header. and still the 3 reads on customer, but that's okay. Looking at the execution plan, much improved because now it's an index seek where it was a scan before. And you want to look for these because these are going to be causing problems. They can cause significant performance problems and potentially deadlocking and slowing down your system. And so that's why these are important to look at. 4 keys, you don't want to just delete them, but you want to make sure that they're not causing problems. And it's just an index to prevent that from causing problems. Now, if you want to learn more about indexing, we do have the Performance Tuning Bootcamp coming up here with Pragmatic Works. That's coming up in November, I believe, the first week of November. That's out in Boston. It's going to be taught by myself, Bradley Balls, and Jorge Segarra. Take a look at that if you're interested more in about indexing and performance tuning in general. I saw that a lot of people that were intermediate on performance tuning. If you're looking for that deep dive, this is an opportunity for that. And if you want more information, check out my blog, email me, leave questions in the queue, and I will get to them and get them blogged about if we don't have time to answer the questions. Thank you for coming out today. I really appreciate everyone for sticking through, and hopefully this was of value. Thank you.